Welcome to the channel. Welcome to another video. If you're visiting for the first time, please like, comment and subscribe. So here we have a British Maths Olympiad round 1 questions 2 from the 2006 paper, and it says to find all integers or whole numbers x, y and z such that x squared plus y squared plus z squared is equals to 2 times y z plus 1 in brackets and x plus y plus z equals to 4018. Now we have to solve the simultaneous equations for x, y and z. Now what I'm going to do is I'm going to tackle this equation here on the left hand side. First thing I'm going to do, I'm going to expand the right hand side. So I'm going to write back x squared plus y squared plus z squared equals to 2yz plus 2. Now if you notice, clearly we have 2yz, we have y squared, and we have z squared. So if we bring 2yz over to the left hand side, and if we bring x squared over to the right hand side, we will have y squared plus z squared minus 2yz equals to 2 minus x squared. Now the key here is I noticed that y squared minus 2yz plus z squared equals to 2 minus x squared. The left hand side, we can make a perfect square. So this becomes y minus z all squared. So what I want to do now is I want to make both sides a difference of 2 squares. So I can do that by splitting the 2 up into 1 plus 1 minus x squared. So now if I minus 1 from both sides, we are going to get brackets y minus z into 2 minus 1 equals to 1 minus x squared. So now both sides are equal. We have a difference of 2 squares. So now we can rewrite that as y minus z one bracket y minus z, and we put plus and minus is equals to bracket 1 bracket 1 plus and minus. So now we can write down a couple of statements. So we'll have y minus z plus 1 is equal to 1 plus x. We'll have also that y minus z plus 1 is equal to 1 minus x. We'll also have that y minus z minus 1 is equal to 1 plus x, and y minus z minus 1 is equal to 1 minus x. So let's remember that our second statement, which we haven't used yet, is x plus y plus z equals to 4018. So now we're going to work this out. We know that y is equal to x plus z, because these two will cancel out, and then we're going to add z to both sides, so we'll have y equals to x plus z. We know that these two will cancel. We're going to add x to both sides, so we're going to get that y plus x is equal to z, because we're going to add x to both sides, and then we're going to add y to both sides, then we're going to subtract 1 from both sides, so we get y plus x equals to z. Then we get that y minus 2 is equal to x plus z. So I'll put a little dash on the z's to differentiate from the 2. And then for the next statement, we're going to get that y plus x is equal to z plus 2. So now we're going to use these statements on the right. We're going to substitute them into x plus y plus z equals to 4018 and see what values we can get for x, y, and z. Right. So for the first one, we're going to substitute in x plus z equals to y. So we have x plus z equals to y. So we're going to get that 2y is equal to 4018. So y is equal to 2009. So that's our first. So we've substituted into this equation, and we get y equals to 2009. We're then going to substitute y plus x equals to z. So if we substitute y plus x equals to z, we're going to get 2z is equal to 4018. So z is equal to 2009. So we've substituted equation 2 into x plus y plus z equals to 4018. We're now going to substitute x plus z equals to y minus 2. So we're going to get 2y minus 2 is equal to 4018. So 2y is equal to 4020, since we're going to add 2 to both sides. So y is equal to 2010. So we've substituted equation 3. So now we're going to substitute equation 4 into x plus y plus z equals to 4018. So we've got that y plus x equal to z plus 2. So that gives us that 2z plus 2 is equal to 4018. So therefore 2z, if we subtract 2 from both sides, gives us 4016. So z is equal to 2008. Okay, so now we've got those values. We can put together some statements to work out what x is. So we know that y equals to 2009, z equals to 2009, so x would have to be 0, because 2009, if we double it, would give us back 4018, because we want to work out y plus z plus x to see whether that is 4018. So we have that y is equal to 2009 and z is equal to 2008. That gives us 4017, so x would equal to 1. Then we have that y is equal to 2010 and z is equal to 2009. So that would give us 2019. Sorry, that would give us 4019, but we want 4018, so x would have to be minus 1. And then we'll have that y is equal to 2010 and z is equal to 2008. So x would have to be 0. Now, this is a Maths Olympiad question. You're not going to have any calculators. You're going to have to check that these values satisfy x squared plus y squared plus z squared equals to 2 times, in brackets, y, z plus 1 close bracket. So what I'm going to do is I'm going to computate one of our values. So we need that. I'm going to computate one set of our values. So we're going to have to show that a set of these values, y, z, and x, satisfy x plus y plus z equals to 4018. X squared plus y squared plus z squared equals to 2 bracket y z plus 1 brackets. So let's have a look at this one. So I'm going to, we already know that it satisfies this equation. So let's see whether it satisfies x squared plus y squared plus z squared equals to 2 bracket yz plus 1 into brackets. So I'm going to do 2000 and plus 10. I'm going to square it. 2000 plus 10. And that's going to give me, when I multiply 2000 by 2000, 4 million. I'm then going to multiply 2000 by 10. That gives me 20,000. This is probably the hardest part of the question, where you have to do these computations. It's a bit rigorous. So we're going to have two of those. So we're going to have 20,000. And then we're going to add 10 times 10, which is 100. So that's going to be 40,000. So I put 40 there. And 100. Add that together. So we've got 0, 0, 1, 0, 4, 0, 4. So that's this squared. Now we're going to square 2009. So in my brackets, I'm going to put 2000 plus 9. I'm just using some skills from algebra, expanding brackets. 2009. So that's going to give me again 4 million plus 18,000. So you're going to have two of those, plus 81. I'm going to be 36, 81. So that gives us 1, 8, 0, 6, 3, 0, 4. So now the next one is to do 1 minus 1 squared. So obviously we have minus 1 squared, which is equal to positive 1. So now we got to add these all up. So this is y squared. This is z squared. And this value here, 1, is x squared. So we got to see whether when we add those up together, it equals to 2 brackets y z plus 1 into 2. So now we've got to take 2000. You've got to take 2010, and we've got to get 2009. We've got to multiply those together, add 1, and then double it. So we're going to do 2000 plus 10 into 2000 plus 9, and then we're going to have to add 1, and then we're going to have to double it. So let's expand. So we get 4 18,000 plus 20,000 plus 90. So we're going to have to add it all up. So that's 38,090. Three, 0, 4. So now we have to add 1 to that. So we get 4,038,091. And we're going to times that by 2. 2, 18, 16, 0, 8. So now we're going to have to take y squared. We're going to add z squared. Then we're going to add 1. So we get 2, 8, 1, 6, 7, 0, 8. So if we know this, that x squared plus z squared plus y squared give us this value here, and we have that when we add together y times z plus 1 and we times it by 2, we get the same value. So this is one of our solutions. You now have to check the others and see whether they satisfy both equations. I'll leave you to do that. You can check. Thanks for watching. Please like, comment, and subscribe, and I'll see you in the next video.